Hi, I'm Solomon, and in this video I'll explain how a linked list can be used internally to implement a stack and a queue, and I'll cover the time complexity of their main operations. With a stack using a linked list, a stack follows the last in, first out, or a LIFO principle. To implement a stack using a linked list, I use the head of the linked list as the top of the stack. This allows all operations to be efficient. For push, I insert a new node at the head of the linked list. This takes a big zero of 1 time because no transversal is required. For pop, I remove the node at the head and update the head pointer. This also runs in a big zero of 1 time. For get top or pick, I simply return the value stored in the head node without removing it, which is a big zero of 1. For is empty, I check whether the head is null. This is also a big zero of 1. Using the head of the linked list makes all stack operation constant time. And when we go to a queue using a linked list, a queue follows the first in, first out, or FIFO principle. To implement a queue efficiently with a linked list, I maintain both a head pointer and a tail pointer. For a queue, I add a new node at the tail and update the tail pointer. This takes a big zero of 1 time. For the queue, I remove the node at the head and move the head pointer to the next node. This also takes a big zero of 1 time. For size, I maintain a counter variable that increments on a queue and decrements on the queue, giving a big zero of 1 time. For is empty, I check if the size is 0 or head is null, which is a big zero of 1. In summary, linked lists are excellent internal structure for stacks and queues because they allow all major operations to run in constant time without shifting elements. Thank you.